A ball of radius 14 has a round hole of radius 5 drilled through its center. Find the volume of the resulting solid. First, as with all of these, you want to sketch a picture so we know what our region's going to be here. So let's go ahead, and I'm actually going to draw the upper half of this sphere, and then I will double it because it's going to be symmetric. It has a radius of 14. Okay, so I can go ahead and put that in here. And then we're going to drill a hole in the center of radius 5. So I'm going to just put that 5 right here and over here. We're going to drill this hole in the center of this thing. So see this hole going down through it. And so the region, if we just looked in the first quadrant, and if we just took this region right here, and we rotated that around the y-axis, we would generate this upper portion of the sphere with the hole in the middle. And then we could double it so that we would have this lower portion down here as well. So here is our region. And because we are rotating around the y-axis, our representative slices are going to go this direction. So we're going to have a little thickness dy. So that tells us when we figure this out, our limits of integration need to be in terms of y, and our functions need to be x as a function of y, expressing the radius or whatever when we have the functions. So let's go ahead and write down this integral. And so our y value is going to go from 0 up to this point right here. So 0 for our lower limit, but we're going to have to figure out what that point right there is. Well, it is a point on this function, and if I want to express this function, it's a portion of the circle. If we wanted to write the equation of a circle, it's x squared plus y squared equals, in this case, 14 squared. We want to solve this for x because we want x as a function of y. So x is going to be, 14 squared is 196 minus y squared. And we'll take the square root. Normally we'd put plus and minus, and that would include this piece and this piece over here and down below. But we are just simply interested in this fourth here, because then as we rotate around we will have the upper half and then we'll double it to have the lower half, so we don't need the negative on there. So this would be this function x is a function of y right here, and I'm interested in what the y value is right there when the x value is 5. So let's put 5 in for x, and we'll solve this. Actually, let's go ahead and square this side, so then this will be 196 minus y squared. So y squared equals 196 minus 25, that's 171. So y is going to be the square root of 171, and this happens to be 9 times 19. And so that's going to be 3 square roots of 19. So our upper limit is 3 square roots of 19. So how do you get these limits? You make a sketch and you look, and I would need to have this go from 0 up to that top point right there, which I just found was 3 square roots of 19. Now I'm going to double it because I want the lower half of this as well. So I'm going to go pi big R, which is all of this, squared. So let's do that. That's going to be pi. This is the x value here, and we found out what that was, and I'm going to square it, so it's going to be 196 minus y squared. Squaring will get rid of the square root. Now I need to subtract off the little r, which is right here, and that little r is just going to be 5. So if the area of that hole, that disk for the hole, is going to be pi r squared. R is 5, so 25 pi. And then dy, our little thickness was dy. Okay, let's see what we can do to work this. Let's factor the pi out. So I've got 2 pi here, and actually then I can combine these two and get 171. When I integrate that, that's going to be 171y. And then I can integrate the minus y squared minus 1/3 y cubed, and we need to evaluate that from 0 to 3 square roots of 19. Now we still have our 2 pi out in front. This would be 171 times 3 square roots of 19 minus 1/3, and then I've got 3 square roots of 19 cubed, and then when we use our lower limit, that's just going to be 0. So let's see what we can do to simplify this, and we'll have the volume. So we have 2 pi times, this is 171 times 3, so that's 513 square roots of 19 minus, over here this 3 will cancel with one of these 3's that gets cubed and leave me a 9 there, but the square root of 19 will get cubed, so it'll leave me a 19 because it'll be 19 squared, and then another square root of 19. So here, let's see, that's going to be 1 carry the 8, so 171 square roots of 19. So it looks like my final answer here, when I multiply that by 2, is 684 square roots of 19 pi.